This is Chapter 6, Lesson 3, Rotations. Let's go to the next page on the right, page 103. How can we best show or describe the change in position of a figure? Well, a rotation, first of all, is a turn around a fixed point. The following notes on the page are a turn or rotation around the origin on the coordinate plane. I have marked a column over here where we're going to have counterclockwise notations around the origin, and over here in the main set of notes, clockwise. Let's focus for right now just on clockwise rotations, and then we will look at counterclockwise. So clockwise goes in the direction of a clock, or in this direction around the origin. So for example, if we had this pre-image, and I know it's a pre-image because there's no prime marks, and I wanted a 90-degree rotation around the origin, clockwise rotation around the origin, it would no longer have A pointing to the left, A prime would be pointing up. So here's one way, an easy way to check. I know 90 degrees makes a right angle. Let's say my pencil is pointing in the direction of A. Where would A prime be pointing? A prime would now go clockwise in this direction. And now it's pointing up this way. Can you see the 90 degrees? So a way to check yourself is, does it point 90 degrees clockwise from this direction to this direction? And then you can do that the same with all the other points too. So if B is pointing down this way, B prime is now pointing this way in this direction. So it goes from this direction here, 90 degrees clockwise. Here's our notation though. You're going to take whatever ordered pair you have, and you're going to put the y value first, and then it's the opposite of x. Remember, this is not necessarily that it's negative, it's the opposite. So here's my example. Let's say that point C is -1, 2. -1 to the left, 2 up. If I follow my form, it says take my y value and put that first. So C prime, my y value in C was 2, my x value now is 2. Just putting that value first. Then the form says to take the opposite of x. So if x is -1, the opposite is +1, I put +1 here. Now these are my new x and y values for C prime. Let's continue on with a 180-degree rotation. So you'll recall that 180 degrees is a straight angle or a straight line. And you can still use the trick that we were discussing. So for example, J. The vertex J on this triangle is pointing up. And if I make a 180-degree rotation clockwise, 90 degrees points to the right, and 180 degrees was pointing down. You see that J prime is indeed pointing down. So the form for this kind of rotation is I take my x and y values, and it's the opposite of each value. Think about how that can make sense, because you're pointing in the opposite direction with 180 degrees. So if J is -1, 4, that's from the origin to the left 1 and up 4, J prime is going to be +1, -4. +1 to the right, -4 down. It's the opposite of each value. And last, for clockwise, let's look at 270-degree rotation. This means 3 90-degree turns clockwise. 3 times 90 is 270. So again, you can try this same concept. If I have my x pointing here, the pre-image, no prime mark, and it's pointing to the right 3 90-degree turns clockwise. 1 90-degree turn, 2 90 degrees is 180, 3 90-degree turns. I am now in this quadrant, quadrant 2, pointing up, and that's what happens. So a way to visually check. But here is the pattern. I take my ordered pair, and I have the opposite of the y value first, and then the x value second. So here's the example with point Z, the vertex Z. Originally it is 1, 3, but I take the opposite of y. If y is 3, the opposite is negative 3. And then I take x. So right in this position, and these are my new x and y terms, my x and y coordinate. So what about counterclockwise? Counterclockwise goes in this direction, the opposite of a clock. How is that notation? Well, we had just looked at 270 degrees clockwise. That's the same as 90 degrees counterclockwise. Think about that, looking back this way. Instead of making the 3 90-degree turns clockwise, just making a single 90-degree counterclockwise gives us the same position. So that's why that form is the same. Counterclockwise, 180 degrees is the exact same, because it doesn't matter if you take 2 90-degree turns to the right or to the left counterclockwise, it's the same. It's always going to be the opposite values in the form. And last, 270 degrees counterclockwise is the same thing as 90 degrees clockwise. That's why this form is the same as the 90 degrees clockwise.